All right, good morning, everyone. I hope you're all doing well. I hope you had a great spring break. Let's look at this first problem for our do now. Hopefully you have a pen and or a paper and pencil or pen with you. So let's factor this following expression. Remember when we are doing these problems, when we see something that says factor, factor the expression, and really we want to do this completely. So that means that we want to make sure that we can factor, as long as we can factor an expression, we want to keep going with it. So let's count the number of terms we have. So we have, that's right, we have 4 terms. So 4 terms tells us that we're going to use what method? That's right, we're going to use left side, right side. And if you're not remembering these, I mean, it's been a week since well, a week and a half since we were doing these problems. Look back at your notes and just look at what we talked about for each of the types of terms. So we have our left side and our right side. What can we factor out of these 2 terms? We're looking for a number and a variable. That's right, we can factor out x's, but no number. So we can take out a maximum number of x to the 3rd power. And we're left with something that would be x to the 5th divided by x to the 3rd will be x squared. Negative 4x cubed divided by x cubed will be negative 4. And then what's the sign between? It's a minus sign. And then what can we divide from 8x squared and 32? That's right, we can factor out a negative 8. And let's see what we're left over with here. So if we take out a negative 8, we're going to have x squared. Positive 32 divided by negative 8 is going to be x squared minus 4. So we can factor out an x squared minus 4. That's a common factor. And we can also have left over x cubed minus 8. Because that's our parts that are in front of those factors. All right, so the question that we ask after we do some sort of factoring is, can we factor more? And notice that we're looking for those special cases. Whoops. So we're looking for these special cases, and that's when we have 2 terms. So 2 terms, we're looking for special cases. So we're looking for difference of squares. We're looking for difference of cubes, and we're looking for sum of cubes. So the things that I'm looking for are, do we have something squared minus something squared? And if we look here, we're like, oh, we do. And remember that if you can look back at your notes, so that's difference of squares. And difference of squares, so we're saying, oh, we have something squared minus something squared. And if you remember correctly, difference of squares becomes a minus b times a plus b. And that's if you start with something that was a squared minus b squared. So what we have is we have x squared minus 2 squared. And then do we have difference of cubes? And I specifically made this problem just so that we can be reminded on both those special cases. We have a x cubed minus 8. And 8 we know is the same as 2 cubed. So we really have x cubed minus 2 cubed. And I could be drawing these closer together. Here, let's move that a little closer there. All right. So, in difference of cubes, if you look back at your notes, and definitely look back at your notes, if you're not doing that, it's not going to be helpful for you. So a cubed minus b cubed, and remember this one, we keep the same sign, so it's going to be a minus b. And then the second part is something that you'll have to make sure to memorize. It's going to be a squared. So if it goes minus, then it goes plus plus. So a squared plus ab, and then plus b squared. So let's use that. So in this case, a is going to be x, b is going to be 2. So I'm just going to rewrite it as this. So it's going to be, and I'm going to go way over here, x minus 2. And then we have x plus 2. And then now this part is going to be, this x is a, and the 2, again, is going to be b, but we're going to put it into this formula here. So it's just going to be, and it's not negative 2, it's positive 2. So it's going to be x minus 2, and then it's going to be x squared 2x and 2 squared. So let's rewrite that. So we have x minus 2. Now we're going to have x squared. And then we have x times 2. So we would rewrite that as 2x. We put the number first. And then we have 2 squared. And we're like, oh, we can actually simplify that. So let's just get our eraser out, erase that, and make it back to that 2 squared is actually going to be 4. So then we're left with this final thing that's completely factored. Even though we're thinking, oh, well, I mean, these are all to the single power, so we know that those aren't going to factor anymore. But this x squared plus 2x plus 4, that's part of this formula, and we know that this part is not factorable. Yes, it has 3 terms. Well, what 2 numbers multiplied together to equal 4? And add up to 2, and it's like, that's not possible. All right, so hopefully that's a good reminder. Now let's look at our agenda or our math talk here. So what I'm going to do is we're going to look at some problems and see. I'm going to give you 3 seconds just to decide, can we factor further? So it's just going to be a sight thing. So let's look at this first one. 3, 2, 1. Yes, you're right. So we can factor this because in this middle factor, we can divide both of these terms by 2. So it would actually look like this then. If we factor them both by 2, we could take out a 2. So it would be a 2 would come out of there. So we're going to factor out a 2. So that 2 would multiply with a 3. So it would be 6x, and then this would be x squared minus 3, and then x plus 1. And the reason why we're doing this is because if we go back to this problem at the start here, sometimes after we factor, we just leave our answer like this, and then we forget that things are still factorable. So that's why we're doing this, this math talk here. All right, so we got that one. Next one, 3, 2, 1. All right, so what did you say? All right, so this one's not factorable. This is a sum of squares. Sum of squares not factorable, difference of squares. So if this was a minus sign, then we could have factored it. And we can't divide either of these 2 numbers. All right, so this one, you're right, we would say no. All right, next one, 3, 2, 1. All right, so this one is difference of squares. So we have x squared minus 25. That we can rewrite as x minus 5 and x plus 5. And then you have this x minus 5 here would still be part of it. And the negative 2 up front would still be part of it. So this was difference of squares. All right, next one. 3, 2, 1. All right, so let's look. So we're looking for, we have a square here. So do we have difference of squares? Well, 27 isn't a perfect square. And then x cubed. X cubed is a perfect cube, but is 4 perfect cube? And we're like, nope, so this one doesn't work. So we're saying on this one, no, we cannot factor. All right, this next one, 3, 2, 1. All right, so yes, you're right. We do have sum of cubes here. 64 is a cube. That is 4 cubed. So that's x cubed plus 4 cubed. And then that would rewrite, I'll just write it up top here. So just like we did for the other one, instead of it being minus, now it's going to be plus. So it's going to be x plus 4. And then it's the same thing. It's going to be a squared minus ab plus b squared. So a squared, so a is x in this case. B is 4. So it's going to be x squared minus, because if it's sum, it's going to be plus minus plus. So we have x squared minus, so now a times b, x times 4. So that would be 4x. And then now we have plus. Notice that this one's always going to be plus. It's just these front 2 switch. And then it's going to be b squared. So b squared would be 4 squared. Oh, and we can simplify that. So let's use the eraser here. Instead of writing 4 squared, we'll write 4 times 4 is 16. All right, nice work on that. So now let's look at today. So we're gonna look at our virtual math lessons. So I'm just gonna talk a little bit about how we're keeping it the same way we've done. We're gonna solve some polynomials, so just one more, and then we're gonna do some volume problems. So we can see volume, remember we're thinking length, width, and height, what you've learned in geometry, and we'll correct that homework that you did before break that was due on that Friday. In our objective, students will be able to solve polynomial equations so we can solve math applications. So we're really looking at this idea of math applications. If you remember before break, I talked about why people, why we need to know about polynomials. It has to do with a lot of things we do on computers now. They end up being written in these polynomial equations that can describe curves, but also we can figure out some volume things and solve problems that way. So just like we did before our typical week today, well, today is Thursday, so you're going to watch a video lesson, correct homework, start new homework. Zoom ops hours will still be from 12 to 2, and then the homework will due at midnight. And then on Tuesday, you'll watch another video, you'll correct the previous homework, start a new homework, and then Zoom ops hours 1 to 3, homework due at 11:59. All right. And then the ops hours, remember, that's optional, but very helpful. There's been a few students that have been taking advantage of it, and they've been getting the help they need. So if you're not finding success in just doing it on your own, make sure to check this out. And then some ninth period things. I'm gonna try to do some groups using Zoom meetings. So for some past standards. So I'll be contacting students individually on that, and then we can either do live quizzes with me, or we could do, I could send practices through Google Classroom with keys, and then we could do quizzes. And the quizzes through Google Classroom or email, I'd have to put like a 1 hour limit on those, and then you'd send them back through there. So these are kind of like two different ways that I'm seeing that we could take care of past standards. And then I'll be contacting you starting next week about that. So solving polynomial equations. So the first thing we want to do, remember this is solving now. So now we know that our answer is going to be something like x equals, and then we're going to write the set of numbers that that goes in there. And we already know the number that we want to look for the x with the largest number. So we have 5, 1, and 3. So we see this 5 here. We're going to be looking at 5 zeros because the n equals 5. We know that we're going to have 5 zeros or 5 solutions. So we're going to have 5 solutions in here. All right, and so remember, they can be repeated because we know polynomials, if they can be repeated if the zero's on the x-axis. Well, all of the real zeros are on the x-axis, but if it's a multiplicity. All right, so first thing we want to do is we want to set it equal to 0. So we're going to have to move this 18x cubed the other side. So we'll have 3x to the 5th. We're going to subtract 18x cubed. And then we'll just put that in the middle. Remember, we want to do the order matters. We want to do the largest, second largest, third largest of x's. And then we count the terms. So we have 1, 2, 3 terms. In 3 terms, we're thinking, that's right. We're looking at doing some RS method. But before we even do that, can we do some simple factoring? So that's what this problem is really looking at. Can we simple factor? Can we factor out a number first or a number of variables? So simple factor is actually what we need to do first. So can we divide a number? Looks like, that's right, 3. So we can factor out a 3. How many x's can we factor out? Oh, it looks like we have 5, 3, and 1. So they all have at least one x. So we're going to factor out a 3x, and we're left with x to the 5th minus 6x squared plus 5. And that's going to be equal to 0. So we already can see that we have one of our factors is going to be 3x equals 0. So this is where we find our zeros or our solutions. So that one we're already going to do soon, but now we have to figure out, oops, looks like I have a mistake there. X to the 5th, we forgot to divide by 4 or by x, so that would be 4. So x to the 4th minus 6x squared plus 5. So how many terms we have here? We already discussed that, so we're going to do the RS method. So R times S equals the A, which is 1, times 5, which would be 5. R plus S, that's right, that equals the middle term, so negative 6. So factors of 5, we have 5 and 1. And then we also have -5 and -1. So those are our possibilities. Which ones add up to -6? All right, so you can see it's this one. So that stretches the middle term. And after looking at your homework, I know that some of us have been stretching the middle term with what I said that you'd make the mistake. It's okay if that's what you did, but what we got to make sure to do is be conscious of that. So it's going to be -5x squared. Some of you are just doing x because that's what the middle term was before when we were doing just quadratics, but it's going to be -5x squared minus x squared plus 5. So notice when you stretch the middle term, it's going to be stretching with these squareds, equals 0. And then now we have 4 terms, so we do left side, right side, just like we do regularly with the RS method. So we can take out an x squared out of here. And I probably don't need to have this anymore because I've already set it equal to 0 over here. So maybe I'll just take that out because it'll make it less confusing for us. Because we've already set that 3x equal to 0 because we know that that's one possibility. And we're just looking for these other 4. All right, so then we're taking our x squared, and then we'll have x squared minus 5. We have a minus sign, and that's right, we can just factor out a -1. So then we have, whoops, uh-oh, that was weird. Let's just go back. All right, so we have, it's because I accidentally pressed the button. All right, so we have, again, x squared, because x squared divided by -1 will be x squared, and then 5 divided by -1 will be -5. All right, now we can take out an x squared minus 5. I see 2 terms, x squared. Is 5 a perfect square? That's right, it's not. All right, I have another x squared. Is 1 a perfect square? And we're like, yes, that is a perfect square. So we can rewrite that one. So again, we have some special cases, or one special case. So this would be x squared minus 1 squared. So that would be then x minus 1 and x plus 1. This is one is for well, the reason is that we don't see 1 as a perfect square, so that one can be difficult to see. All right, so now what we have to do is we have to set these equal to 0. So over here we have x squared minus 5 equals 0. We have x minus 1 equals 0. And we have x plus 1 equals 0. These ones we can see that, so this is going to be x equals 0. This will be x squared equals a positive 5. So I'm going to add 5 to both sides. A number equals, or I'm sorry, something squared equals a number. So it's going to be x equals plus or minus the square root of that number. Can't simplify. And then add 1 to both sides. So x equals 1. Subtract 1 to both sides. X equals -1. So our zeros are here. And then these ones. And let's count up these number of zeros. So we have 1 solution. We have 2 right here, plus square root of 5, minus square root of 5. And then we have 2 more, so that's 5. So if we write this out, we have x equals, and then we have, and if we put these in order, we could do negative square root of 5, -1, 0, 1, and then square root of 5. We could have also written this, I mean, if you wanted to, you could write it out this way as well. You could just say x equals, and then set notation, you could say plus or minus square root of 5, plus or minus 1, and then 0. You can write it like this. This would be perfectly fine as well. So either one of these. All right, so let's keep moving on. So oh, no, we're not going to do that one. So we're solve for x if the volume is 16 cubic units. So notice that we're doing these math applications. So what does it mean to solve for x if the volume is 16 cubic inches? And we have this as our volume. Now, what we notice is that, well, and to help you draw this out, to draw a cube, what I find useful is you just draw the first side. You draw a rectangle, and then what you can do is you can just draw these three lines back at the same time and just back at an angle, and then you're just going to connect the tops. Notice that this looks transparent. It looks like it can either be up, well, this one's showing the inside. We can just show it like this. So again, you make that rectangle, draw those angles out, and then you just connect it at the top. All right, so volume, so we're just solving for x, it says, and it says if the volume is 16 cubic inches. So we know that volume equals 16 cubic inches, or cubic units, it says. And what do we know volume is? That's right, it's going to be our length, our width, and our height, or length, depth, and height, or however you want to look at it. So we know that volume equals those things, length times width times our height. So if we use that idea together, so V is equal to both of them, then it means that 16 equals length times width times height. So we can write our length, x, times our width, x minus 2, times our height, x minus 2, equals our volume, 16. And this is really a system of equations, because here's one equation, here's another, and we're just setting them equal to each other. All right, so let's multiply this out. So we have x, and then let's multiply these two parts together. So we have x times x is x squared, x times negative 2, negative 2 times x, negative 2 times negative 2, positive 4, equals 16. Remember, our goal is to set it equal to 0, so we can see what method we're going to use to solve it. We can do some simplifying here. These two are like terms. So we still have x squared minus 4x plus 4 equals 16. Then we can multiply that x in, so we have x cubed minus 4x squared plus 4x. And then the 16, remember, we got to move to the other side, so we can subtract 16, because we're going to move that 16 to the other side. So then now it's going to equal 0, because these two are going to cancel out. All right, so I'll just rewrite it over here. So we have x cubed minus 4x squared plus 4x minus 16 equals 0. How are we going to solve this? Yeah, that's right. We got to count the terms. So how many terms do we have? We have 4 terms. What method do we use to solve 4 terms? All right, left side, right side. So that means we're going to factor the left side, factor the right side. So what factors out here? That's right, x squared, x minus 4. What factors the left side? That's right, we have a positive 4. All right, and then, yep, that's right, we got to factor out the x minus 4. All right, and then what do we do next? That's right, we have to solve for 0. So x minus 4 equals 0. X squared plus 4 equals 0. And notice that we're finding 3 possibilities for x here. So this will be x equals 4. Oh, so that's a positive number. That makes sense, right? Like this could be 4. This would then be 2. X, or 4 minus 2 would equal 2. So our width would be 2. Height would be also 2. I wrote a 0 there, but I said 2. And then this would have been 4. All right, so 4 is a possibility. Let's see if we have any more possibilities. So x squared equals negative 4. X equals plus or minus the square root of negative 4. And we're like, oh, negative 4. So that's plus or minus square root of 4, square root of negative 1. So square root of negative 1, that's I. Are we going to have imaginary solutions? You're right, we can't have imaginary solutions. So this is not a possibility. So really, our only possible solution is going to be that positive 4. So But in this problem just said to solve for x. So really our answer, I just circled it, x equals 4. Sometimes these problems might say, they might ask for the dimensions, or they might ask for a length or a width. So we have to be careful on what the question's asking for. This one just said solve for x. All right, so let's go on to correcting our homework here. We'll come back to that problem on another day. So we're gonna factor, here's your answer key for practice 4. So this is what you did before break. Some of you notice that this is not a difference of squares, so you can't factor that further. No difference of squares here. This one, you had a difference of squares. You might have something that was like 4z squared minus 1. That's a difference of 2 squares, and that factored to this. Oh, that x should be a z. All right, and then for this one, we had 3 solutions with that s there. 4 solutions, so that's what we have. These are square roots here. So those are all square roots. And this is actually, let me rewrite this out. So it's negative square root of 3, square root of 3, and then negative square root, and this is a fraction, 8/3 times I, and this is square root of 8/3 I. And these do simplify further, but it's fine to leave them like this for our purposes here. And then this is negative square root of 6i and square root of 6i. So remember that I is on the outside. All right. And then so these are these problems. If you have questions, again, 3 terms we were thinking, RS method, RS method, RS method. Oh, that's right. These are all about the RS method. I forgot about that. Okay. Moving on to the next one. So here's your homework. Here's questions 1 and 2. Again, pause it, draw them, solve them. And here's number 3, 4, 5, and 6. So again, be careful on the directions. Factor, find the solutions, factor, find the solutions, factor completely, right? Find the solutions of the equation. How many solutions are you expecting? How many solutions are you expecting? All right, and then your ticket out for today. What is the difference between factoring a polynomial and solving a polynomial? So make sure to write that out on in your notes as well. And you don't need to send me your notes. You just need to send me your assignment. So again, your assignment. This assignment is due Friday at 11:59. All right, so you have 2 days to do the assignment and to watch the video. All right, so I hope you all have a great day. I will see you again on Tuesday morning. Have a good weekend.